So, as a request from going over the homework on Monday, you wanted some videos to show how to write the paragraph proofs for number 30 and number 31. So let's break it down. The first thing we have to do is we have to draw a picture that matches the scenario that's given. That way we can kind of visualize what's happening. Point Y is the midpoint of YZ. So let's draw a segment. I'll do it over here on the right. So we got X, Z, and we have some midpoint Y. And midpoint means that the two line segments created by that midpoint are congruent. Next up says Z is the midpoint, so I've already got that Z there of the segment YW. So I'm going to go from Y to Z, and I'm going to continue the line out to line W. And since Z is the midpoint there, we know that those two segments that we just drew a relationship for are also congruent. And our ultimate goal, I'll highlight it in pink here, is to prove that XY is congruent to ZW. So here you can see there's kind of like this overlapping part in the middle there with the YZ where they are both seem to be congruent to it. That's the trick to this. I see a transitive property being used in that. Two things are both congruent to the same part in the middle, and that gives me the clue that I need to write out this paragraph proof. So, given Y is the midpoint of XZ and Z is the midpoint of YW, we will show XY is congruent to ZW. So first thing we need to do is set up this relationship between X, Y, and YZ. Those two red marks there. How did I know those red marks? Well, by definition of the midpoint. By definition of the midpoint, segment XY is congruent to segment YZ. Also, I used a comma there, so I shouldn't capitalize. Also, by definition of midpoint, YZ is congruent to ZW. That's the green tick mark saying that those two things are congruent by the definition of the midpoint Z. Therefore, XY, and I'm going to highlight it here. I'll highlight it in yellow. Here we've got two pairs of congruent things. XY is congruent to YZ, and YZ is congruent to ZW. Since it's two different segments are congruent to the same segment, then they are congruent to each other by the transitive property of congruence. And there's the end of my proof. Now let's do number 31. So we're going to be using midpoints again, which kind of gives me a clue. I'll probably use the definition of midpoint. Let's draw the picture here. Point L is the midpoint of JK. So I'm going to draw JK and put L as the midpoint. And that's going to tell me that these two things are congruent. JK, the line I just drew, intersects MK at K. And that makes sense because they both have K in the name. So now I can draw this other line, M, MK. They intersect at K, so that matches. And now they're giving us this little bit of information here. MK is congruent to JL. So MK is congruent to JL. Prove that LK is congruent to MK. So our last little bit is we're trying to show LK and MK are congruent to each other. Well, two things happen to be congruent to the same segment. Notice I have the same marks here. That means I'm going to be using the transitive property again. We just have to set everything up so that we have all the pieces lined up so that we can use that transitive property. So, given L is the midpoint of JK and JK intersects MK. Oh, I forgot my line over JK. MK at point K. And so that makes sense that I'm writing them together in a combined sentence, right? I still have more given information. So the way that you can write that down is just saying that you're continuing on with the given information. You can just say as well as, which is saying, hey, this is also given. Or you could just say also given is, and then your statement, MK is congruent to JL. We will show LK is congruent to MK. So, we already have one of our congruence statements. I'll underline it in yellow here. What we need is the other congruence statement, and we're going to get that from the definition of midpoint. So, what two segments are congruent because of the midpoint? Well, we know that JL is congruent to LK. By definition of midpoint. So now those are the red tick marks I'm taking care of. And one thing here, I might look at this now and say, you know what? I don't like that because they don't line up exactly for the transitive property. I need to switch one of them. So LK, notice how I'm trying to get it match LK being in the front there, just like I want for the statement I want to prove, is congruent to JL by the symmetric property. And now I'm going to highlight. And I do this, you don't have to highlight in the problem at all. I'm doing it to make it clear how I'm coming to the next step in the conclusion. I know that MK is congruent to JL, and that JL is congruent to LK. So you can see in both of those pairs, we have oh, you know what? Maybe I didn't need the symmetric property because now they're not lined up, right? Before, the JL and the LK were lined up. JL was at the second part and JL was in the first part. So I'm actually going to cross this part out here. I didn't need to use the symmetric property. I have two angles, MK and LK, congruent to the same angle, JL. So I'm able to use the transitive property. MK is congruent to LK. Now I've used the transitive property. The transitive property. I'll pause for 1 second. Sorry, the shower's getting started. If I had good editing software, I would just edit it out, but it would also take me like another half hour. Maybe if I just talk louder. I don't want to talk too loud, though. Okay, we're good. All right. Now, the big thing I want to point out here, and I will circle this in blue. The statement we're trying to show is LK is congruent to MK. But I don't have that. I have MK is congruent to LK. This is where I want to use the symmetric property. I'm just going to flip the order of those two things, and then those two blue boxed statements will be exactly the same. So LK is congruent to MK by the symmetric. We spell symmetry, right? Symmetric property. So you can see I knew I was going to have to use the symmetric property at some point because I assumed that they weren't lined up correctly, but they were. So I crossed it out. And now that I'm done and I can see that crossed out section, I've taken care of it now, I can actually delete that whole line and change that to a period. And we are done with our proof.